Hey everybody. Okay, let's talk about how to actually compute the moments of inertia. Okay, so let's pick an example of a simple shape, like a triangle, with base b, height h. Alright, let's find the moment of inertia. Ix, Iy, and the product of inertia, Ixy. So Ix is y squared dA. Iy is x squared dA. The product of inertia Ixy is xy dA. And our strategy is, let's decompose into Cartesian components. So dA, we just split into dy dx. And then just do that double integral. And you know how to compute centroids. So you have the math skills to do this. So for this particular example, we're integrating in the y direction from here to here. Right, so this function down here, for this example, is y equals 0. This function up here is rise over run, h over b, x, plus the y-intercept is 0. Okay, and then these are the limits of integration in the y direction, and in the x direction from 0 to b. Okay, so these same for all of these. All right, so let's try one of them. Well, let's do all of them. Okay, so Ix, y squared dy dx, from 0 to h over b x, and from 0 to b. So let's integrate y squared dy, y cubed over 3, from 0 to h over b x. Okay, so let's evaluate this integral. So that's h cubed over b cubed. Let's not forget that 3, x cubed. Okay. All right, let's now integrate this. Let me move the constant out of here. Okay, so x cubed dx is x4 over 4 from 0 to b. All right, so let's evaluate that. So that's b to the 4th over 4. Okay, let's gather terms here. So we got b4 over b3, so h cubed b over 12. There we go. So that's Ix. Let's try Iy. So right here, x squared dy dx. Same limits of integration. Okay, let's integrate x squared dy. So that's x squared y from 0 to h over bx. Let's evaluate this integral. X squared, okay, so that's h over b x. Okay, let's see x squared and x. Let's just write it as x cubed. Okay, let's evaluate this integral. x4 over 4 from 0 to b. So then that's h b 4th over b, so cubed over 4. All right, that's Iy. Now let's do the product of inertia. X, y, dy dx. Okay, so let's integrate x, y, dy. So that's x, y squared over 2 from 0 to h over bx. Okay, let's evaluate this integral. So that's going to be square it. So h squared over b squared x squared. And let's not forget that 2. Okay. And we have x and x squared, so I'm just going to write x cubed. Okay, now let's evaluate this integral. Let me write this constant over here. Okay, so x cubed dx is x4 over 4 from 0 to b. Okay, so we got h squared b to the 4th over b squared. So that's b squared over 2 times 4, 8. So there we go. We got ix, iy, and the product of inertia ixy. So that's the method. So you can use this for any, like if it's whatever shape or whatever function to whatever function, you know the method. For simple geometric shapes such as these, however, you can just look in the appendix, which I have right here. Like for a triangle, they're for different shapes: triangle, rectangle, circle, semicircle. And look at our answers were here: 1/12 bh cubed. That's what we got here. Iy 1/4 hb cubed. That's what we got here. Ixy 1/8 b squared h squared. That's what we got. Okay, so for simple shapes, you can just use the appendix, but I was just showing you the method. Okay, so give this a try and then keep on studying. Let me know if you have questions, and I'll see you on the next video.